Right, today's lesson, we're going to look at aqueous electrolysis. Now, this one is a bit harder than the molten electrolysis because we have an extra 2 ions to worry about. So aqueous, first of all, means dissolved in water. Now, water is H2O. H2O can actually decompose, okay, partially, to form H plus and OH minus ions. So whenever we deal with these questions, we have to consider the H plus and the OH minus. So let's go over some examples that have been taken directly from your syllabus. Let's start with sodium chloride because we did that one before when we did the molten electrolysis, and the outcome is actually quite different. So we're going to look at sodium chloride, aqueous. We shall also look at copper sulfate, aqueous. We shall look at sulfuric acid, aqueous, and we'll just slip in. What else can we slip in? We can slip in magnesium bromide. And just for fun, let's put in a nitrate. Let's put copper nitrate. Okay, that should be more than enough examples for me to go through with you. And as a result, I will mention the rules of electrolysis, which will be in the notes. And there'll be 2 new rules you need to learn about the anode and cathode. So anode is positive, cathode is negative. So if we talk about the anode rule first, the anode rule is as follows. So in the anode, this is the rule. If a halide is present, it always discharges to form a halogen. Otherwise, oxygen forms from the OH minus hydroxide ion. So that means this is a halide, that's a halide. This one, and this one are not halides. So we would get the oxygen forming instead. The second rule is the cathode rule. And the rule is, you can put it in different ways, but if the metal is more reactive than hydrogen, then hydrogen is formed. Only copper, silver, gold, and platinum are less reactive. So unless you have one of these, you will always get hydrogen. So if you think about the periodic table, most of the time you're going to get hydrogen as your equation. Now, let's have a look at what we have in stock for you. First one, sodium chloride. It's very important that you write out all the ions present before you start. So the NaCl will result in Na plus and it will result in Cl minus. The water will result in H plus and OH minus. You will need to select which of those is going to go where and which one will be preferred. If we start with anode, we have 2 negatives that are going to compete against each other. However, the rule is that if a halide is present, it always forms, so Cl minus will go here at the expense of the hydroxide. So think of the halide as being the first place champion team that always wins. And think of the OH minus as being the second place team that can only win if the halide is not there. Now, on the other end, the negative electrode, we have a competition between these 2 positive ions or cations. Now, sodium is more reactive than hydrogen, which means you get hydrogen, not sodium. And this is the difference to the previous lesson where NaCl molten formed sodium here. We're actually going to form hydrogen here. So for the half equations, this one I'm expecting you to know now. 2x minus goes to x2 plus 2e minus. So it's going to go to Cl2 plus 2e minus. You just need to know this. Now the H plus one needs to add an electron to become a neutral H. But because H likes to be diatomic, we need to double these. So that's my reduction. This is my oxidation. Because I took these two out, these two are going to remain. So the solution will appear alkaline because it will have OH minus ions floating. It'll basically have sodium hydroxide. So if you add universal indicator, it will actually go blue. Now we move on to the copper sulfate one. We write out the ions first. Wait a minute. I just rubbed out the title. Doesn't matter. The important thing is that we write Cu2 plus and H plus as being the two positives, and SO42 minus and OH minus as being the two negatives. Once again, we have to select a winner. So for the anode, is there a halide? No, there's no group 7. Otherwise, oxygen forms from OH minus. That means OH minus is actually going to go here. Copper is less reactive than hydrogen, so you actually get copper, not hydrogen here. So I'm going to cross out copper, and you'll be left with these. These are actually going to form sulfuric acid, so it will be acidic in solution, interestingly enough, if you add universal indicator. Back to these. This one's easier. Remember, you always match the charge of the metal ion with the number of electrons. So you would add 2 electrons to make copper. For the OH minus one, this is the hard one. I recommend learning it, but I'll show you how to construct it. You kind of have to know that it forms water and oxygen and electrons, because there's negativity on the left, electrons always go on the right. So as long as you remember it makes water and oxygen, you can try and balance it. So you'll notice 3 oxygens, but 1 here, and 2 H's, but 1 here. What you do is you double your waters because you want to get an even number. Now you have 4 hydrogens, and you have 2 times 1 is 2, plus 2 is 4. So you have 4 oxygens as well. So if you put a 4 here, everything is balanced except the charge. Because you have 4 negatives, you have 4 electrons here. And this is the famous equation that produces oxygen gas. If you want to put state symbols, by the way, AQ, gas, AQ, gas, AQ. Now in this one, it's not very hot, so the metal is actually a solid. This is AQ. Water is always L. This one is gas. So you get bubbles forming, and you get a red-brown deposit for the copper metal. So this was one of the rare examples where you have a metal less reactive. Next, we move on to H2SO4. That one is actually not too bad because we have H plus from this and H plus from water. So there's only one positive ion. So that goes here. And the equation is the same as this. For the SO4, we have SO42 minus. And of course, we have OH minus. Once again, the rule was that if a halide is not present, the hydroxide forms. So you're actually going to get the same equation again. If you had to describe this in words, you would say that the negative hydroxide is present due to water, and it attracts to the positive electrode because opposites attract, and it loses electrons. Right, this one, we have Mg2 plus and H plus from the water, Br minus and OH minus from the water. So once again, if the metal is more reactive than hydrogen is formed. Well, magnesium is more reactive than hydrogen, so you're going to form hydrogen here. So the same equation again, notice. That's why it's so important to memorize it for the hydrogen ion. So that's now gone, and the halide is present this time, so the halide is the champion that goes here. So you get the same scenario as the Cl minus, but with Brs. So the famous 2x minus going to x2 plus 2e minus. Once again, you'll be left with an alkaline solution of magnesium hydroxide. And the last one we have Cu2 plus and NO3 minus. We also have H plus and OH minus. Now, copper is less reactive than hydrogen, so the copper will go to the negative electrode. So you get the same equation as this. Now, the nitrate is not on here, but nitrate is not a halide. So that means the second place team wins, which is the hydroxide. So you get that same long equation of 4OH minus going to 2H2O plus O2 plus 4E minus. And the key thing is that you observe bubbles of oxygen. You're left with H plus and NO3 minus, which means you can form HNO3, which means you're left with an acidic stuff behind. So all anode reactions are losing electrons, so they're oxidation. And all cathode reactions are reduction because they're gaining electrons. And that really is the full cause for the purpose of the EdXL IGCSE. If you do AQA, then I will do one extra lesson on industrial electrolysis. Otherwise, this is all you need to know. It is a bit difficult. I'm going to save this. I have plenty of worksheets attached with solutions. I recommend you practice it. But in the end of the day, if you learn these two simple rules, you should be fine. And to reiterate these rules, they're repeated here. At the cathode, you always get reduction, and you always add electrons. The less reactive one essentially forms. So the less reactive one is compared to hydrogen. So copper, silver, gold, and platinum are the only ones that are below hydrogen. Easy way to remember them is they form a backwards L shape here. So copper, silver, gold, and platinum form a backwards L shape. They're the only metals less reactive than hydrogen. All the other ones are more reactive, so you will get hydrogen. Then these are the two equations possible. There's no other possibility in aqueous electrolysis. It's either the 2x minus or the 4OH minus. Just learn it at the end of the day. Thank you for listening, and I will see you next lesson.